All right, this is going to be adding and subtracting fractions, and we're going to start off with the fraction 1/2 plus 1/3. We're going to start with that fraction problem. And I showed in class where the first step there, it says get common denominators, and I wanted to talk about why we need common denominators. So if I have 1/2 and I have 1/3, they are not the same size, so it is really difficult to say how much that is as a total. And we're comparing that, of course, back to 1 whole. So if this is 1 whole, can't fit it all in there, but if this is 1 whole, half of that means that I cut it into 2 pieces and I took 1 of the 2 pieces. And if I cut it into 3 pieces, then I took 1 of the 3 pieces. But when I can compare this back to the half, this is half of the whole and this is 1/3 of the whole, but when I put them together, I can't really explain how much I have unless they're cut into the same size pieces. Now, if I tried to cut this in the halves into thirds, I can't add another third on there. It will overhang. It will go right past it. So that won't work out for us. So I can't do thirds. So I'm going to take a look at and do possibly sixths. And I can find that as well, that I need to do sixths. And I'll show you how to do that in a minute. But if I take and do sixths, I see that I can do sixths and I can get exactly the same amount using sixths as I can with a half. And you'll notice not just 1/6, but it takes 3 of those. So that means that 1/2 is equivalent or the same amount as 3/6. With 1/3, I can see that we've got 1/3 can be 2/6, which means that 1/3 is the same amount of my chocolate bar as 2/6 of it is. Once I have them as the same size, I can't say 1/2 and 1/3 and come up with how much is gone, but I can say 1, 2, 3, 4, 5 sixths have been eaten. So that's how I will be able to do them, but I have to have these same size pieces. And of course, if I had all of them on there, that would be 6 sixths. So we have 5 sixths, which is 1 short of that. So that's one way to model it, and you can draw those things on your own paper if you don't have the fraction bars to use. So mathematically, without that model, what does that mean? How will I do that? Well, I take a look and I've got 2 and 3 as my denominators. And so I'm going to count by 2s, and I'll count by 3s. And the first thing that I run into that they have in common, that's going to be my common denominator. So my 1/2 is going to turn into something with a 6 on the bottom, and my 1/3 is going to turn into something with 6 in the denominator. Now when I look at that, I can say, well, in order to get from 2 to 6, I had to go 1, 2, 3 times to get there. That means I also have to go times 3 to get there. And it makes sense because 3 out of 6 is the same thing as 1/2 of something. So those are equivalent to each other. So now I have 3/6 that I can add in there. And to get from 3 to 6, I can multiply by 2. So that is 2/6. And I can go vertically or I can go horizontally, however you prefer there. Erase that so if we come back it's not confusing. And then 3/6 plus 2/6 would be 5/6, which is what we found with our model. The same thing's going to occur over here with 1/3 and 1/4, and I once again have some blocks here to model it. Now last time the sixths worked for us, and we can try that again. We know that 2/6 equal 1/3. But when I come down here to my 4th, I cannot get those same size pieces. There's too much. In fact, there's like almost half of it lapping over. So I'm going to try 12ths. So we can see down here that if I cut these into 12ths, in other words, 12 of these small pieces would be needed to make the whole candy bar, I can see that 4 of those equal 1/3, and 3 of them equal 1/4. So now that we fit perfectly, we can see that total we've got 1, 2, 3, 4, 5, 6, 7, 7/12 when I add these two together. Sorry about that. Some of the magnetism on my desk is messing with the magnets that I'm working with up here. So we can see that mathematically, if I start with 1/3 and 1/4 and I count by 3s, and I count by 4s, that it is indeed the 12 that I run into. So my 1/3 and my 1/4, if I want a 12 in the bottom, I have to think 1, 2, 3, 4 to get there. So times 4 and times 3, which means times 3 as well. So I get 4/12 plus 3/12, which equals 7/12, which is also what we saw in our model. What I would like you to do is pause the video and try this problem and see if you get the same answer as I do. All right, so once you've worked out that problem, you find out that you get 18/45 plus 15/45, and I get a total of 33/45, and I can reduce that. I can divide both of these by 3. 33 divided by 3 is 11, and 45 divided by 3 is 15. So there is my final answer, 11/15. The next problem I'm going to show you is this mixed number problem, and I showed this one way in class, and I'm going to show both ways. I can turn this into an improper fraction, which I am sure you are used to doing. This ends up with some huge numbers and lots of division at the end. It is not my favorite way to do it. So I'm going to show you a little shortcut. I like to take these problems and I like to write them vertically. Now when I look at this, we know when we add whole numbers, I would add the ones column and then I would add the tens column, and I could carry over to here. I can do the same thing. All I need to do is get myself a common denominator to do that. So if I look at these two, I can do by the 5, 10, 15, 20, 25, 30, 35. And I'm like, oh, 35 is going to be the first one. So I'm going to multiply these both by 5, and that will get me 20 over 35, which means I'm going to multiply both these by 7 and get 14 over 35. So I now have 3 and 14 35ths plus 1 and 20 35ths. 14 plus 20 is 34 over that 35, that common denominator that we found, and 3 plus 1 is 4. I think that's a lot easier than turning this into an improper fraction and then getting this huge numerator, and then you have to add, and then you have to go back and you have to do division. And I just think that is a lot of extra steps to do, and all you have to do is this. I want you guys to try the subtraction ones. They are the same as the addition ones, only you're subtracting when you get there. For instance, this one already has a common denominator, so bulk of my work is done for me there. I'm going to keep that common denominator, and then 15 minus 3 is 12. I look at that and I go, I can reduce at least by 2, and if I take a closer look, I notice that 12 is half of 24. So my answer is 1/2. Go ahead and pause and try this one right here and this one right here, and then I'll come back and I will do this one with you. Go ahead and check your work on this one. You're going to want to pause it because I'm going to hit pause and go on to the next one. Here's our next one. Ended up with an answer of 1/5, so make sure you have these steps written down. This one I only had to change one of the denominators, so that made it a little bit different. I'm now going to move on to the last problem. This is another mixed number problem, and I'm going to show you particularly why I like to write these up and down. So 5 1/8 minus 2 and 5 24ths. When I write them up and down, this reminds me that not only do I need to subtract my 5 minus my 2, I also need to do my 1/8 minus my 5 24ths. I'm going to show this to you with borrowing. I'm also going to show it to you when you figure it out at the end, both of which will work. So right now I've got 24 as a denominator and 8. And I can't reduce this one with the 24 down to the 8 because that 5 is a prime number. So there's nothing I can divide both of these by. But I can multiply this one to get to 24. So if I multiply times 3, I get 24 here. And if I multiply times 3, I get 3 up top. Now if I'm looking at that, I'm doing 3 minus 5. For years you've been told you cannot do that. That is absolutely not the case. You can do 3 minus 5. You just get a negative 2. Now the other thing I can do to keep from getting that negative 2 down here is that I can borrow from here. I can make this a 4. When I give 1 over here, I'm going to give that 1 in the form of 24 24ths. So when I add that on there, this now becomes 27 24ths. So what I'm now looking at is 4 and 27 24ths minus 2 and 5 24ths. 27 minus 5 is 22, and 4 minus 2 is 2, and then I can reduce and get 2 and 11 12ths. If I don't want to do that borrowing, I have my 4 and 3 24ths minus my 2 and 5 24ths. 3 minus 5 is a negative 2 24ths. Sorry, this was a 5 originally, wasn't it? 5 minus 2 is a 3. Well, this is 3 minus 2 24ths. That would be like I have $3 and I spend a quarter. Well, it's going to drop me down to 2. So I have to be able to think of my 3 as 2 plus 1. I'm then going to think of my 1 the same way I thought of it as here, as 24 24ths. So now it's 2 plus 24 over 24, so that's still 2 plus 1, which is still 3. And I'm going to subtract my 2 24ths, which gives me 2 and 22 24ths, which still reduces down to 2 and 11 12ths. Hopefully this was helpful. Let me know if you have any questions.